RL circuit definition 1.36 RL circuit is given by this formula L didt plus Ri equal to Et. This equation models the amount of current It in amperes in a circuit containing resistance R in ohms, inductance L in henries, and an electromotive force Et in volts. The sum of the voltage drop across the inductor L didt here and the voltage drop across the resistor Ri is equal to the impressed voltage Et, where L is the inductance and R is the resistance. Both L and R are constants. The current It is called the response of the system. So we want to solve example 1.41. Two 9-volt batteries are connected to a series in which the inductance is 1/4 Henry and the resistance is 8 ohms. The current I of the initial current is 0. Okay, so what we obtain from this sentence, two 9-volt battery represent the value of E, which is the total voltage. So since it has 2, so we do the multiplication 2 times 9 volts. So E equal to 18 volts. And then from this sentence, inductance in 1/4 Henry, so you obtain the parameter of L. L represent inductance, L is 1/4. Next, resistance is 8 ohms. Now we know that the resistance R equal to 8 ohms. Determine the current I if the initial current is 0. So we have initial condition. At time 0, the current is 0. Okay, so by using the previous governing equation for RL circuit, we take this formula, okay, L didt plus Ri equal to Et. Okay, then we substitute the corresponding value where L is 1/4, R is 8, and E is 18. Okay, so this is first order equation. So for first order, we can solve by using direct integration or separation of variable or techniques, linear techniques. So based on this type of equation, the most suitable technique is by using linear. Okay, where the format of linear is the form of dy dx plus pxy equal to qx. So the format is written in terms of dy dx, but in our case it is di dt. So you have to know that y should be replaced by I and x should be replaced by t. So based on this formula, now the format should be written by d from here, okay, we want to write the format in terms of I and t. So di dt plus pti equal to qt. Now this is the format of the first order linear. Now you can see that from the format there is no value, means that the coefficient of di dt is 1. Since our problem consists of this value other than 1, so we have to make it 1. So how to do that? So we can multiply the entire equation by 4 so that the parameter value here, the coefficient here, become 1. So now you can obtain di dt plus 8 times 4 is 32i equal to 18 times 4 is 72. Now you follow the exact format where the coefficient here is 1, and then you can find pt and also qt. So to identify this, your pt is 32 and your qt is 72. So we can perform the first step in linear technique. So for the first step, we want to find the integrating factor. So the original formula is written by rho x equal to exponent integrate px dx. So based on our case, we should replace x to t and y to I. So means that you have to find a rho t exponent of pt dt. Your p is 32. So now you know that the integrating factor is just exponent 32t. Step number 2, multiply the entire equation by a rho t. So means that your current equations should be multiplied by rho, which is E32t. So now you obtain this equation. Okay. After you multiply the entire equation by rho, the third step involves restating the left-hand side in the form of d dx in bracket rho y. But remember, in our case, x should be replaced by t, rho is E32t, y should be replaced by I. And the right-hand side remain the same. Okay, the next steps, let's integrate both sides. So here you can see that the integration made with differentiation, we just have the value inside the bracket. You just copy what it is. For the right hand side is the integration of this value. So this integration implies this value, right? Then we can simplify 72 over 32 is 9 over 4. What we have here is E32i. Remember, we want I as the function. So you should divide everything by the exponent to obtain I equal to 9 over 4 plus CE negative 32t. Okay, where this term is cancelled, and then for this term we bring it to the upper part, so it becomes negative. So this is your general solution, where the solution involves C. We have one unknown here, which is C. You can find C by using the initial condition. where we set earlier from the problem I0 equal to 0, so means that at t equal to 0 the current is 0. So we replace into the equation, okay, then you can get your C is negative 9/4. Finally, thus your final answer is I equal 9/4 minus 9/4 E negative 32t. So this is the particular solution.